Hello and welcome everyone to another exciting virtual panel in the TechGig Leaders Circle. I'm Sukriti, the Senior Manager Events and Alliances at TechGig, and I'm delighted to be your host for today's Power Pack panel discussion. Our topic for today is engineering in the AI era, rethinking developer workflows. Now, with AI accelerating at the breakneck speed, engineering teams are being reshaped, retooled, and redefined. Now, from writing better code to managing secure platforms, AI is leaving no function untouched. We have a distinguished panel of leaders with us today who are driving this transformation at the very top of their organizations. Let's meet them. Joining us today, we have Mr. Jay Chandran Ramachandran, who is the Senior Vice President, Artificial Intelligence Labs at C5I. A visionary in AI and R&D, Jayachandran is leading high-impact initiatives at the intersection of machine learning, automation, and enterprise transformation. We have Mr. Vasu Kothamasu, who is the General Manager and Global Engineering Leader at Content Stack. Vasu brings a deep product mindset and platform first engineering approach and has been instrumental in shaping developer experiences globally. And we have Mr. Rohan Vaidya, who is the Area Vice President, India and SARC at CyberArk. Rohan is a seasoned cybersecurity expert focusing on secure digital transformation and identity-centric DevSecOps strategies. A warm welcome to all of you, and thank you so much for joining us for this conversation, gentlemen. Okay, so to begin with, let's touch base with our first segment where we talk about reshaping the entire developer workflows across organization. Jachandra, I'd like to begin with you. AI is clearly augmenting the developer productivity from coding assistance to automated testing and deployment. Have you seen AI practically change developer workflows in the last couple of years, and what's on the horizon in terms of AI-powered engineering capabilities in today's time?
Right. It's a great question in the kind of era we are in, right, at this point in time. So maybe we may need to go a little back in the horizon as well in terms of how it actually kind of started, right? If you look at like the early 70s and 80s, like that's the time actually, I mean, a lot of a very tactical systems are actually getting built. And if you look at like those days, I mean, languages like assembly and COBOL and those kind of stuff are actually big in those point in time. And people are actually doing like small automations. It's like very point automation specific to whatever they're actually doing. It was never looked at it from a very holistic perspective at a very high level system automation or a complete enterprise kind of automation and those kind of stuff. Very pointed specific productivity enhancements people were actually doing. They were writing some shell scripts to automate few processes and other stuff. And post that, actually we kind of moved into an era of like the rise of the integrated development environments, right, and building systems using that. We had like the arrival of Visual Studio, and we actually seen different versions of such tools actually emerging, and more actually capabilities actually getting built. Post that, actually we kind of moved into the era of, let's say, our continuous integration, wherein actually, I mean, after every phase in the software development life cycle, we have been able to kind of continuously do some integration of the particular components, and as well as like automate some of this what we call as like the DevOps, right? How do we kind of test it and kind of deploy it? So some level of automation has been kind of brought in each of those the life cycle phases as well. After that, actually we kind of moved into a kind of world where a lot of machine learning and AI enabled kind of capabilities were actually brought in. So these kind of tools, horizontal tools, keep evolving over a period of time, and we have seen like code analysis tools, like for example the Sonar Cube, and some of the early assistants like Tab9 and other stuff actually came into picture. And we would also see like something like the in the world of DevOps as well, things like Ansible and Terraform, which actually simplified this whole infrastructure as a kind of a capability, right? And including like the arrival of Kubernetes as well. So a lot of these components actually kept evolving, and it was almost like we never had an end-to-end kind of play till that particular time. So every 10 years, actually, we kind of kept on improving on actually what we had the previous. A lot of transformation happened, but nothing of that this particular scale at this point in time actually we are seeing that hasn't actually happened. So we are at this point in time, the post the arrival of the chat gpt and the subsequent models, pretty much like any tool in the market actually you see, all of them are actually embedded with some of these large language models at this point in time. If any such product or a tool is not having any of these LLM capabilities, I don't think there is a lot of scope for them to survive at this point in time. So if you look at like this whole the software development life cycle and then the involvement of the developers in that process, um, we actually see like pretty much every life cycle is actually impacted. For example, in my own world, we have actually experimented with tools like GitHub Copilot, and we have seen like a tremendous improvement, especially in the coding phase. But however, like when it comes to the phases like the requirement analysis and converting them to the epics and stories and features and those kind of stuff, plus the areas like the architecture and design and other stuff, it has not been like making a lot of high impact, though it can make some impact. For example, we were able to kind of translate some of these requirements into, okay, hey, convert this into epics and stories and those kind of stuff. So it is able to do that level of documentation. Of course, it needs intervention to kind of review and then kind of update it as well as per those requirements. And then post that, if you get into the, let's say, the architectural phase and design phase, based on like specific kind of inputs actually you can provide from a non-functional point of view. For example, from a, let's say, scalability point of view, or the preferred architectural stack you actually kind of have in your mind, it can actually propose some of those components, though it may not be able to draw some diagrams and other stuff using Copilot, but definitely it can propose what of those significant components you can have. And from the architecture, based on these requirements, it is also able to provide some high level pseudocode in terms of how actually you can define this particular system. Post that, but there is definitely a lot of human and the tool kind of collaboration which is actually required to make it successful. Okay, so at every phase there is a deeper involvement which is actually required, and that means you need a strong knowledge on what actually you are building, because end of the day, what actually you put as a prompt, how good it is, that is going to define the quality of the output as well. Okay, so then subsequently when you get to the coding phase, that is where actually we see a significant improvement. And the reason being like why it is actually having so much improvement is like these language models have been trained on a large corpus of code as well, and these code are predominantly like what was available publicly on the net. Okay, so if your programming language is something which has been like kind of widely available prior to the these LLMs and other stuff, and you used to, let's say, use GitHub, or maybe you used to check Stack Overflow kind of platforms for code. If the languages are available there, then the likelihood of these tools actually giving good code is very high, because end of the day, it's like your output is as good as like the languages on which it is actually trained on. So you need to make a conscious call on which of these programming languages you really want to use this tool and not. Depending on that, your efficiency may be high or low. For example, some of the programming languages may be something like, let's say, COBOL or assembly language or some embedded system languages. You may not find a lot of benefit. It may be like very low productivity on that particular area. But if you're actually focused on, let's say, Java and Python and those kind of programming languages, the likelihood of you getting a very high productivity is actually very high. The level of automation is going to be high, very high. Some people can get 30%, somebody can get 50%, 60%, whatever may be the range, right? So different kind of range actually you can get on the coding side. Similarly, like when it comes to unit testing as well, based on the code generated, these tools are able to generate some decent test cases which actually you can execute and then check the results as well. So coding and unit testing is like where significant efficiency actually we are seeing at this point in time. However, like the remaining phases, as I said in the beginning, like you have your the design phase, the architecture phase, then the system testing phase, deployment, and those phases, it may not be like giving a lot of benefit, and that's what we have also seen in our own world as well. But one good thing actually is like it helps in some of the phases which actually developers hate. For example, documentation. Okay, developers actually just hate documentation. It actually helps in a substantial way. And for example, we ourselves, when we actually write a code, and at the end of the project only usually we are asked to write the documentation, and people like write some documentation and just submit it, and for the sake of it, it never actually helps the team which is actually going to take up the production support and maintenance and others, and actually they literally suffer. So there is actually a kind of a friction happening between the development team and the production support team and other stuff. So it actually, in a way, these tools actually help to create a better collaborative and a cordial relationship, in fact, with the different teams as well. So I feel like across the software development life cycle, we have been able to embrace tools like GitHub Copilot, and some people may use Cursor or Windsurf or any of those things. It's up to them, but there is a definitely a great potential for adoption of these tools and then improve as we move forward in this life cycle. So in terms of the horizon, if you see, like, what I feel is like, as actually these tools actually evolve with the underlying foundation models actually enable them, what's going to happen is like the areas actually where we are seeing lower level of automation, they will actually keep coming up. Okay. So that's kind of a tactical intervention which is going to happen. So your architecture phase, design phase, and then let's say system testing phase, deployment phase, you can see like more and more automation, or the level of automation actually increasing in those areas. That's like at a tactical level because they keep improving in a continuous way. But you can actually look at it like at a very different level. We are also coming up with like tools are coming up with like this agentic capability. Okay, so it can become like, instead of you kind of continuously prompting and generating code, and then it actually you are responsible for integrating and other kind of stuff, the likelihood of like agents taking over that particular job is going to be very high. For example, the like the way we structure the team as well. Someone is actually responsible for, let's say, all user management and let's say admin as part of the application. Okay. Somebody is responsible for, let's say, backend. Somebody is responsible for front end. Somebody is responsible for a module like, let's say, payment gateway alone, right? So all these modules can be kind of independent agents actually responsible for it and then developing them. And there could be like some overarching integrating agent which is actually responsible for putting all these things together and then creating that holistic application. So things can actually move from a maturity point of view towards that particular space. And the role of developer is going to be like increasingly responsible for managing these agents and then make sure like it actually works as per expectations. It's no longer like you may be a developer, a senior developer or a developer lead and other stuff. Your team would consist of, let's say, two or three developers plus, let's say, 10 agents. And so it's going to be like very a digital plus human kind of a team you might be managing very soon in the future. Already it's happening, but that's going to be the new normal we would anticipate.
I would like to move to Vasu now. Vasu, from the engineering standpoint, I mean, Jay gave us a pretty much detailed background of what the entire tactical perspective looks like. But from the engineering standpoint, help us understand that how do you see AI helping developers go beyond the efficiency? Because I think that is one of the important cores that leaders like you look at in the areas like ideation, prototyping, or the user feedback loops, because I think that is one of the most important elements that needs to be addressed when we talk of the business goals.
Yeah, thanks, Sukriti. Jay, that was a very good overview of where we are heading. Actually, I totally agree. I don't know how many of us really realize this. We are in an unprecedented era of disruption, like never before. We never had this kind of a disruption. Internet, everything disrupted, but then this tech Gen AI disruption is at a much, much higher level. Very good one, actually. In fact, we should be fortunate. We are very fortunate that we are in this era. And I personally believe that November 30, 2022, when ChatGPT was released, that was the beginning. That was the beginning of that disruption in the software development and the life of a developer. I don't think all the developers in this world have realized that's the day that everything has changed, right? And over a period of time, a lot of models enhanced and a lot of things have changed. Jay talked about few of these things. AI has changed everything. The way now we are building this software much, much faster than any one of us could have imagined. At least I did not personally imagine that it would be at this pace. I understood this will be the thing, but then the pace is a little faster than what I've actually thought. It's just been 2.5 years. Can we imagine? Just 2.5 years. And we are talking about all these things. A lot of everything changed. The workflows, the developers now use everything has changed. Developers have these GitHub copilots, cursors, everything giving the boilerplate code. Tack, done. When we are typing, suggestions pop up before we complete the typing. I've been a big fan of pair programming all my life. As an engineer, people think like pair programming is not you're wasting two headcount to do something job, but then it is actually more effective, and you develop the overall code faster. That's what is my belief, and I've seen it live as well. Now, can you imagine? This is happening live with a machine, not another human being. And this machine, though the LLM models, to some extent, are much better than some of the other co-engineer that you're being. So that's real pair programming with a machine in a better way. That's phenomenal, actually. Yeah. Now, what does that mean for the developers? Developers now have the luxury. They have the luxury of time, and there is a responsibility that comes with this time. They have the ability to think beyond the code and the syntax. That gives us the ability to start asking the right questions. What is the business impact of what I'm doing? Usually these things come at a later point in your career, but those things can come at an early point in your career. The outcomes that we are driving, because the software code and everything is finally driving some outcome. So you have the ability to trying to understand all those outcomes at a much early stage. And for the developer, there is this big shift that is happening where you're not now anymore focused about just about execution. You can move on to understanding the intention of what you are doing actually. Now, these are the aspects that you get to understand at a later point in your career. But at a
Right.
very early stage, now you get that chance of understanding this thing because now you have the time. Now you need to use this time judiciously, cautiously, don't goof up, but now you have that ability. Then something, I mean, we have cases where something could take about 2 weeks to develop or being developed in 2 3 days, and some things in few hours as well. And all these things give the engineers the opportunity to double down and ask the why questions. Earlier, it was all about how do I get this done? How do I get this done? But now you can start thinking about why. Why? That's the most important thing. I've seen product managers using vibe coding and doing the prototypes. I was like, my God, what's happening actually? I've seen the UX designers using these AI tooling and building the entire UI mockups just about in few hours. What used to take a couple of weeks or maybe 1 week, 2 weeks, now can be done in few hours actually. Look at the productivity and all the time that it has now, right? But for an engineer, what does it mean actually? We have to start thinking something that you've been doing daily can be done just like that. So it's an opportunity to improve that efficiency and move up the stack. And what does that stack mean for a junior engineer who used to just write the code and take long time mentorship and somebody else doing it, reviewing it and finding the edge cases on your code? Now you can do it yourself. That's for a junior developer. And for a senior developer, you can start focusing not just about all those things, but also the architecture, which an architect used to do. And for an architect, you can start thinking about the impact your product is making. So it's all about improving that efficiency as an engineer, as a human being, and moving up the stack. So essentially, I can see that happening already where the engineer's role has changed and they're becoming more and more efficient. And then that they're driving more things. And then that overall stack is actually going at a much faster pace for them. It is still the same path, but then
Yeah.
it is at a faster pace. So that's what is happening with the efficiencies actually. So a lot of things are happening. Great period actually. Yeah, absolutely amazing period.
Okay, a follow-up to what you've just set up the pretext, Vasu, and I completely echo your thoughts here. The kind of disruption that we have seen, I mean, being a non-tech
Yeah,
person here, the kind of improvement and innovation that we have seen happening almost every day for the developer community is phenomenal. Now, platform engineering is becoming a strategic pillar in the modern DevOps, and we all agree to
yeah.
that. How do you define the platform engineering in today's AI first context? Because you said 2022 was a major disruption part. And what role do you think it plays in standardizing or simplifying the developer experience? Because when you say we've just got started, or we can look at the hows and whys of technicalities, I think it's an experience where we can shorten our lengthy tasks and focus onto the priorities of a business goal, right?
Yeah,
So
yeah.
how do you see that?
Okay, let me just simply bluntly tell you all this thing. Platform engineering is no more a nice to have kind of a thing. Mature organizations have figured out this thing at some stage in their path that it's an absolute enabler for all your teams. In the world of a developer, there's a lot of things that it's a complex world. When the system is complex, sometimes it's chaotic as well.
Yeah.
But the platform engineering is what brings sanity, calmness, and order to all these products that are enabled by the platform. That's the first thing about the platform engineering.
Okay.
Great platform engineering teams are not just adding these layers of processes or something. They actually remove the friction of getting
Mhm.
things done better. They are tools, standards, guardrails that allow individual product teams to run faster, improve the velocity. That's what the platform engineering teams do usually. And great teams usually actually do those kind of things. With AI, there is another dimension. There is another dimension. AI also, I see aiding different products and everything, but there is an also AI platform teams. They're
Okay.
not just about like any other platform team, like an authentication service or a logging service. It's not one of those things. It is also one of those, but it is beyond that. And I see actually two roles that these platform teams or AI platform teams playing. AI models are maturing very, very fast. I mean, every week a new model, new thing is getting launched, and people keep moving and thinking like, oh my God, something is now new. Let's try it.
Yeah.
And there should be guardrails. There should be guardrails in the usage within the organization. There should definitely be the guardrails. These are not bureaucratic things, but then there should be guardrails in the usage, and that is not possible for every product team to have implement those guardrails within an organization. It is absolutely not possible in my opinion. Is it realistic? Yeah, but then it will take much longer time to do such things actually. Having these AI platform teams will enable in the right way of this usage of AI platforms within the individual products. That's the first and primary role of an AI platform team. Centralized platform teams standardizing the usage of AI within all the products. That's the
Okay.
first and foremost rule. Um, and there is another second one. In my opinion, that is a lot more important than the first one. First one will happen. Everybody will figure it out. That's not a in my opinion, that's not a big deal. Everybody will eventually figure out whether it's 2 months, 3 months, 6 months later, they'll figure out and they'll do it. But the second role of an AI platform team is much more important. It is about the evangelizing the usage of AI in the right way within the organizations. In a large engineering teams spanning 200, 500,000 member teams, engineering teams in a large organizations, there should be that evangelizing that needs to happen. How to use the right way, the AI, the best possible way within the products, championing the usage of AI within the organizations, not just product development as an engineering, but across the other functions like the finance, sales, marketing. There's a lot of those things. These are the AI platform centralized teams that needs to do that, and building that AI first culture. That's the most important thing, actually. Second role that these platform teams play. Not many organizations that I come across, they are doing that, but this is an important role actually. And I'm very happy to say at Content Stack, we have identified this need very early in the cycle. We hired a leader. Don't try to groom somebody internally. If it's there, do it. But then we've hired a senior leader and built a platform team around that individual, evangelize the usage of AI. I'm very glad that it has been an extremely successful experiment. Now, not anymore, but that's the second role. So that's the two main things that the AI platform team should be doing.
All right, now I'll move to the third segment, which talks about how do we build this AI first engineering culture across organization. And I think Rohan, you're the right person who can actually talk about the mindset, the governance, the alignment, because it's not just about tooling anymore. It's not just about the technicalities. It's not just about you're aligning, the teams here, but it's also having a mindset that gives you a secured lens of these functionalities. Now, what does an AI first engineering culture mean to you from the security and scalability lens? And how can leaders foster that within their teams?
So when I look at AI first engineering as a culture, when more from the security or scalability lens, I think the first conversation which happens with everybody about AI as a tool is something which fundamentally needs to be changed, saying that this AI is going to be a foundational principle of how we build products, how they're designed and secured by default. It's not an afterthought any longer. So if you start considering AI as a tool, I think you are still way away from where you want to be there. I mean, the culture is much later, so it has to be a foundational principle. It's a part of your organization. It's a part of. It's like an assistant or somebody who is a part of your team. I think adopting that in all functions of the organization as AI as a part of your team is important rather than a tool which is there. If I look at it more from a security perspective, because there is less of a conversation when it comes to an AI tool on security from a day-to-day user in an organization. There may be some people in the organization who could have very different views about security, saying you don't give it to them, or there may be very liberal people who would say give it to everybody. It is not about even having a balance. It is about really understanding in detail as to what AI can and cannot do from a security perspective, and what we need to look at it. So one of the things that you look at it is proactively threat modeling of the proactive threat modeling of an AI system is very important, like to understand the attack surface, because this is a new story. This is a new era that we are in, and the attack surface are very different. Like an attack surface of an AI ML pipeline could be something like an model poisoning or a data drift or a prompt injection. Now these are things which are very new in the cybersecurity business also. So that is something which needs to be understood very well. Then building security in the AI life cycle is very important. It's not just about getting an AI tool, but from the data collection to the model training to the deployment and then monitoring, the entire life cycle of the AI, the security needs to be built in at all stages. Then we talk about the guardrails of AI use. Implement a policy-driven access to models and databases. So this becomes a part of your structure when you start building it up. Monitor for usage or something like an unexpected behavior, because we've started hearing a very new term, hallucination. Not that the term is new, but machines hallucinating is something which is very new, right? So start looking at whether the machines, whatever you're doing, are they really hallucinating? Are they really, especially when it comes to a Gen AI, there is a very big challenge that they start making their own stories. So can we really start looking at it? Then it's about also in terms of how do you make sure that your AI decisions are traceable and secure? Because if the model starts misbehaving and you have no way of tracing the anomaly, there's a big challenge, because then it is like blind faith. You start doing those things, then becomes a challenge. So there is a need from a guardrail perspective to start looking at these areas. Then also the infrastructure, securing the infrastructure for AI workloads is very important. I think that is a lot of miss which happens because the projects just run from different parts of the organization, different BUs fund it, and they don't really go centrally go back to the CIO or the infrastructure team or the cloud teams to really keep allocating doing it. Because once you say AI now in an organization, people immediately put money on the table, and then there are a lot of Robin Hoods in each of the organizations or each of the parts of the organizations who want to run their own projects, and then they try to do their own stuff. So I think that is an important part of protecting the training data. Then the model artifacts and the encryptions have to have an identity management solution running around it. Who can access, who cannot access is an important part, because this is all sensitive data. A lot of things could be very strategic to the organization and things like those. Then also one of the things in cybersecurity, which is now a lot of conversation around it, is a zero trust architecture. And that is something which we haven't seen. I mean, being in the cybersecurity business, and we talk to customers where we haven't seen this coming in the AI pipeline, or the multi-tenant platforms in the AI architectures that people are building it. So I think there's a need to bring in those best practices from the general cybersecurity thing to the AI part of it. When it comes to scalability perspective, I think there was a lot of conversation on the platform thinking. So again, building a AI from a scalable internal service, AI, it could be an API driven or a reusable component, is an important part of it. Otherwise, you're going to keep reorganizing and regenerating and doing the same, starting the same thing over and over again. Leveraging infrastructure as a code to dynamically scale training and inference workloads is a very good part of it, which a lot of organizations have started doing it, because they've started realizing that there is a lot of knowledge, especially with the developer community, lying in different parts of the organization, and we can really use that over and over again. Then it could be the kind of auto scaling that you need to put in, or the cost performance trade-offs that will happen, and things like those from an autonomous data driven ops that we need to start building. And I think those don't really exist unless and until you are an AI build company. So maybe in a company like an OpenAI or in Microsoft or something, they may have those things, but I think it's necessary to start building those things in smaller organizations or organizations which use AI for development, but are not really an AI organization, or AI build organizations which are there. The ML observability and governance is also an important part of it, because the tracking of databases, the features and the models become very, very important. And the feedback to, the loops which go back to the models is something which have to be either restrained or scaled based on what the capabilities are. So those are things which are very important in terms of how you would do that. And then I can just kind of divert a little bit to say that when you are in the leadership role, how do you foster this culture within the organization? So I think one is to normalize the AI literature engineering, because AI is still looked at as some kind of a rocket science, and it's a cool thing to know and have. So I think normalizing that AI literature from an engineering perspective is important. Upscaling the engineers from the AI fundamentals, the security risks, especially the ethics implications, because once you're building a product or you're building certain things, the ethics becomes a large part of the whole story. Making AI literacy as a baselining in every developer organization is very important, because you need to start somewhere. So you need to start doing some baselining around those part of it. Uh, I have started believing that when you start talking about security too loudly in an organization, people start pushing you back. So making governance invisible but effective is something which is very important. So you start embedding the automated policies into the development life cycle. That is important. The moment you start telling the developer that this is a security issue and this and all that thing, he's just going to start pushing back. or he's going to listen to you, but then you use his backdoor to figure out multiple things to do that. So I think, making it invisible is very important, but making it in effect very, very effective is important part of it. Then the other part which I've seen successful AI organization or people who've been able to do it, they've been able to lead with some good use cases. So they start small, they kind of find leaders, or I would say champions, who really go and talk about or evangelize what he talked about or Vasu talked about in terms of where the quick wins are, get people excited, and then you start doing a lot of things which work. Secondly, I think encouraging experiments till with guardrails, because normally in a test environment you would never use guardrails, you would do everything under the sun, and then you would say, okay, now I would start putting all the guardrails as an afterthought. So I think when you start a project, or you start implementing, or you start experimenting, if you start going with those, I think there is an import, there is something that people will start doing it. So start using sandboxes and start doing, it's safe to fail kind of a situation and learn. So those are areas, if we start, I think we should be able to start doing it. So, I mean, if every engineer thinks how AI can be a multiplier, a force multiplier, safely, responsibly, and scalably, I think we'll be able to navigate this thing much more better.
Fantastic. I quite like how you've put things together from the securities, lenses, Rohan. I'll now move to the next very important part, which is people enablement and the developer growth in the AI era, which you've just, touched base that how we can actually look at and have a perspective at. Ajay, I'd like to come to you. As AI, handles more routine tasks, right? How are organizations upskilling developers to stay ahead and grow in this new paradigm?
Yep. Okay. So I think that's actually very important. The reason being, like, there is a drastic change actually which has happened in the whole the software development world, right? Um, but one thing actually I wanted to kind of highlight is like, um, though there is a lot of improvement in terms of these tools are able to create some nice code, and it works as well, but at the same time, I firmly believe that as developers, we should not be just losing a skill when it comes to coding. Okay, it should not be like we just rely on the tool, because there is a danger when actually you over rely on something. Okay, for example, let's say I'm fresh out of college and I'm given this tool, the GitHub Copilot, and now I need to develop something. Okay, and I'm not very proficient in terms of a particular programming language, maybe Java or Python or anything, and I start believing that whatever actually this tool is going to give me as an output is correct. Okay, so that is where actually the over reliance actually becomes dangerous. So we need to be proficient in coding. It's not going away, because as you kind of elevate yourself right to the next level or so, how do you elevate? I mean, without skills you just cannot elevate. You're not saying that, okay, I have a tool and because of that I'm actually skilled. You should be able to review the code which is actually given by the tool as well, and see whether it actually is satisfying the different, let's say, the stories and the features and other stuff which are actually expected, not only from a functional point of view, at the same time from a non-functional point of view as well. The whole the system thinking and platform engineering and all those stuff actually we spoke about, right? Because these tools are not there yet to kind of take care of your system thinking as well as like the platform engineering kind of needs. Okay, so these they are still in early stages. So unless we kind of develop the core programming skills and be in a point of control, that is actually very important. I would put the word like you should be in control, not the tool. So only with that actually you would be able to kind of create some applications which can actually be evolving, at the same time maintained and in the long run as well. So coding is not going away, so you need to learn the coding. One good thing is like with these tools kind of available, you can actually learn that much faster. So use the tool to your strength and not the other way. So you keep learning faster. Earlier, like when we used to code, we used to look at like whatever code was available. Many a times nobody coded from scratch. There was always something which existed, and then people actually leveraged that, modified it, and that's how the whole evolution of coding itself happened, right? So that's not going away. Number two is like, are we going to limit ourselves to only like the programming languages which is there available in these tools? How will like new programming languages actually evolve, right? I mean, are we going to restrict ourselves to, let's say, Java and Python and React and others? How will the new programming languages evolve which are like much more abstracted and much more faster than actually what we have? So there is a need for those kind of skills as well to create new programming languages, because none of these language models will have the capability to create a new programming language. They're trained on something which already exists. The new doesn't exist in these tools, so we need to have those capabilities. So unless you actually develop the strong coding capabilities and algorithm capabilities, you can't do that great stuff, right? So that's very important. Number two is like, how do we kind of, now we are in this world, it's not like I can't be like oblivious of the fact that this is actually existing, right? I need to be aware this is actually existing and I need to kind of evolve along with that. So definitely everyone need to undergo some level of basic training in artificial intelligence, and then the generative AI, the large language models. What are the different tools in the market for different life cycle phases? How do I kind of embrace those tools into my regular scheme of work? And at the same time, like there are a lot of stuff publicly available as well, right? I mean, for example, all these big tech companies like Google, Microsoft, AWS, they are actually churning out so much of program, so much of training programs, which all of us can actually take up and then upskill ourselves on those specific platform. Because most of the products or kind of the clients who you might work for are already on these platforms. It is actually very important to kind of learn AI in the context of platform and not learn something isolated. So that's something I would suggest. Number two is like, always be kind of eager to kind of participate in some of these hackathons and events and other stuff. So that's actually the world wherein actually you can try out your new skills. And in a hackathon, like there is no performance appraisal or anything, right? You go and like kind of nobody's evaluating you and rating you for the annual bonus or something like that. Just take that and then experiment that, see where you stand, keep learning. So that's a very good opportunity available externally. And within the organization as well, for example, my organization, we conduct a lot of ideathon and hackathon multiple times in a year, so that you get to do things within your organization as well and improve actually what actually you are doing. So not only learning, but at the same time applying those learning to build something good, which can help you to learn as well as like in your career as well. So that's actually very important. The other thing I would actually suggest is like, as we kind of start using these tools and then um, reduce the amount of effort actually we put for actually literally sitting and coding, right? We can actually take up new tasks in terms of like system design and architecture and DevOps and platform engineering and those kind of stuff. So develop those skills as well, because as I said, a at this point in time is limited to doing a coding automation kind of stuff, but not doing some higher level thinking and the engineering and that kind of sort of things, right? So better to develop those kind of skills, because you need to guide this tool to your benefit, and unless you have these broader skills, it is very difficult to kind of guide these tools to get what actually you need to do. The next thing, actually, you can do a lot of experimentation with these tools. So don't be stuck with like one tool. New tools will keep emerging, so that a part of the time you should devote to like what's new arriving in the market, how can I actually try out those tools and then do the stuff. The other thing I would say is like, um, we can actually be, as engineers, we are not good at storytelling. Okay, so how do you kind of present what we do to the world? How do we kind of use the power of AI to help us kind of tell nice stories? Okay, so for example, the instead of going and presenting in front of your manager, you can actually use the AI as a sounding board and present and then take feedback. Hey, how am I doing this? How did I do this demo? Did I do it well? What can I actually improve on, right? You can actually define a set of criteria and saying that, am I performing or scoring a, let's say, a 5 on 5 on each of these criteria? How well did will my stakeholder get convinced if I do it this way? Am I kind of pacing it in the right way? Am I addressing all the segments of my presentation? So you can get very nice feedback, if I would say better than your manager, okay, for that matter. Then always like continuously learn, and at the same time get some certifications as well, because that always brings credibility to what you know, but at the same time do a lot of experimentation, because experimentational learning is like the best way to kind of learn, and at the same time remember and apply as well. So I would just put it that way.
All right. I will now move to the last segment in the interest of time quickly. And Vasu, I'd like you to address the ethical dimension here. We spoke of how the line between human decision making and machine suggestion is like sort of thinning and sort of blurring, like there's a confusion that we see. What should our developers and engineering leaders watch out for when building or relying on AI driven systems? Are there any common ethical traps or red flags that I should quote? Also, audience, right after Vasu answers this question, we'll have your questions put up to our speakers, which our co-host Aditya will ask. So, Vasu, go ahead, please.
This is a big one, actually. This is a very big one on the ethics part. AI and ethics is it's a very loaded topic. Rohan covered some parts of it already. Jay also covered a few parts of it. AI definitely accelerates in the development and everything, but the way we should always treat this is ethics should be that anchor for guiding us moving forward. Without ethics, then we'll go to some place where we nobody wants to be there. I've been a big fan of automation. Anything that can be automated should be automated. Very, very simple. That's have been my principle. And there's nothing wrong in it. It makes our life easier. But with the AI agents and the automation, it's a totally different thing because we have to do this very, very carefully. Like Rohan mentioned some time ago, AI models have bias. They hallucinate. They depend on the response depends on the data that is being used for the training. The users of this, they may not understand all these parts, right? We develop the tooling, we develop the products and everything, but the final end users may not really understand how the model is trained, what's the biases, what's the algorithms that they use. Is it designed for convenience, fairness? The end user may not know that. So as a leader in your organizations, is it part of every developer mindset in this one? Not an easy thing, but then as a leader, you need to understand these things and do embed these parts, the biases, what kind of generate responses that it gives, check whether it is having any edge cases that it is not doing, remove the hallucinations and everything, and make it transparent to the end user who are using, and let them decide. If we are not doing that, right, then I think that's where we are bordering on the ethics part. We're not providing all the disclosures. So in a regular world, we have these disclosures when you buy some stocks from some stock suggestions from a stockbroker. The stockbrokers are supposed to give the disclosures. Do they have any stake in that stock, right? Did they recommend that stock as part of a brokerage? All those are disclosures. Exactly on those lines, anytime we do these AI automation agents and everything, we should be providing those disclosures in a way, transparent way for the end user to understand. And this is not an easy thing, but we should be able to figure out. And in the age of AI automation, it's our job. It's our job to make sure we don't compromise the speed, but then we also don't go at such a speed where we're compromising on our integrity. And for me, that's the most important part to balance how the speed and ethics have to be managed in this world of AI. Not an easy thing, but I think everyone will figure out their own way of doing it. But always disclose the boundary conditions, what you have tested, what you have not tested, so that informed decisions can be made by the end users.
Okay, so let's begin with the questions that we have for today. We have some very interesting questions, and I would want to take them for all of you. We have a question from Sapna. What are some unconventional methods that your organization uses to support developer well-being, motivation, and continuous learning? Any one of you can take
No,
this. We're
maybe I
good.
can take that.
Yes, Fasil, please go
So
ahead.
what we have done is it's a okay. I don't know what is the expectation, but then I'll tell you guys what we do at Content Stack.
Vasu, you're not
Um,
audible.
I'm not audible.
Yeah, he is audible.
You're audible.
Yeah.
Okay, I
Yeah,
didn't change any of my settings or anything, so
go
it
ahead.
should be
No problem.
audible. Yeah. So basically, we kind of provide and there is a budget, but then it is not unlimited, but it is a very generous budget on the L&D, and we mandate 40 hours of training. Anything you pick and choose, whatever you need. It's not whatever whatever the individual wants to learn, we do that. Any tooling the engineers need, no questions. I mean, there will be some questions, but then practically no questions. Like I said, there are individuals who are using GitHub Copilot. There are individuals who are using Cursor. It's your choice, but you can't use both of them. Any conferences that you need to attend that benefits your overall growth, no questions, we fund it. And for some of the teams, there is a mandatory 40 hours of training, any training that you do, but a mandatory 40 hours to upskill yourself. We identify the gaps, new technologies. And these are not necessarily gaps. Like, for example, AI specifically, the engineering leader that I mentioned, Suryan, what he has done is he has come up with 5 belts, like a white belt to the black belt, and then categorized what it means to achieve in each of these belts. And then we did a survey where individuals are, and then we are up leveling each of them to get to the not everybody at the black belt, but the orange belt. So that's one way of up leveling your organization in the things, and then all these things are provided in a safe environment. So there's nothing like a failure. Provide the ability, freedom to let them do whatever they need, and ultimately over a period of time, that all comes back with compounded interest in the overall organization ability to deliver something better.
Yeah.
That's what we do at Content Stack.
So just to add on to what Vasu mentioned, see, one other thing actually we have embarked on is like when all these trainings and enablement and all those stuff is like good, but it doesn't actually move the needle. Okay, so the most important thing is like if you really want to kind of be true to what we call as democratization of AI, right? You really need to give the power of that into the hands of everyone who's actually working, okay, in the organization. And if you have to do that, then you really need to provide those enablers to them so that they can actually do the experimentation themselves. For example, today, as the panel members spoke, people have access to these tools. I mean, they can quickly design something, they can quickly prototype, and they quickly experiment as well in their scheme of work, right? They are not building something for the enterprise. They may be building a very small utility for themselves. So that's where actually we provide that enablement to them so that they can actually use like very simple tools available in the market, a Figma or a Lovable or Cursor or something. They can actually quickly build something and then feel the power of AI, because ChatGPT kind of it provides the taste for them, okay, how AI would actually look like. But if they really want to do something on their own and experiment, that's where actually this tool actually helps them to build something and be confident about AI. That's actually the most important thing. And that actually builds the culture within the organization that, yes, of course, I can also build something with AI.
Fantastic. I have a question from Soham. He's asking practitioners can move up the stack, but sometimes AI hallucinates and the solution may be not appropriate. Do you feel that we still need expert review and validation?
So I'll take that question. I think one of the things that we should start you treating AI more as a collaborator rather than a crutch. And what it means is that AI tools can accelerate coding, testing, debugging, but they don't really understand your system's context or the business logic where like a human being. So treating AI as a co-pilot means typically is that critically reviewing the AI generated codes instead of blindly copy pasting them. So I think that's one of the very important parts which really helps. Asking why. I mean, Vasu was talking about the why which comes in, and not just what. Understanding the reason behind every suggestion is very important. So when you have the code generators basically telling you, showing you thinking, and then it keeps starts showing you all the steps they take. I think instead of just admiring on what they're doing, asking or critically thinking as to why it is really happening is really going to help on that. And then using AI to level up is an important part. I mean, where I am, if I can go to from an A step to B step, I think that really helps to take it's not just checking their output, but basically using that output as a learning and sharpen your own skills. I think that is a very big uh, self tutor or a proctor that you get to really help you at any point of time to really keep improving.
So just to add to what Rohan has said, actually,
Please.
AI will never make a bad developer a good developer. Never. So, if a developer doesn't know coding and doesn't understand the logic and those things, AI will not. AI will not distract that make. If you are a bad driver who doesn't know driving, you use the best of the cars or this any car. It doesn't matter. You'll do accidents. It's exactly the same. You should be understanding the logic. You need to. It is assisting you be more efficient. It is not doing your job actually. I mean, maybe in some ways it is doing, but then it is not. So you still need to understand the logic. You need to do the right things.
All right. I have another interesting question from Mahesh. He says, as AI becomes more embedded in the developer tools, how do you differentiate between productivity gains and over reliance on the automation?
Let me take that question. So, see, first of all, we are at a point wherein actually the things are actually moving very, very fast. Okay. So, uh, to define a baseline, okay, the only baseline we have at this point in time is like we can say what it would take to build a particular functionality if it were to be done manually, okay, or whatever you tools we had prior to, let's say, using it to Copilot or Cursor or any of those kind of stuff, right? So that is like the basic thing which is be required to baseline somewhere. This is my estimation framework, and this is my the process capability baseline at any point in time, right? Unless you have a base, you can't see what is improvement. So first and foremost, as organizations, we need to have a baseline of that. Post that, actually we can look at like using these tools, what kind of efficiencies actually you get in each of these particular phases. For that, you have to run pilots. That is the only way. You don't have data to say that okay, this is now going to take what used to take 10 days is going to take 1 day. There is no data. Without data you can't do anything. So to bring predictability into that, you need to run different kind of pilots within your organization, because your repo is like not same as like my repo or Vasu's repo or anything, right? Everything is different and everything has got its own complexity. So the whole environment complexity, the kind of skill of the developer, the kind of programs you're actually working on. Are you working on a services kind of a project? Are you working on a SaaS product? Or it all differs. So many permutation combination of factors come in to see like what kind of productivity actually you can get in. So define your baseline, run pilots, baseline that, and then see like what kind of efficiency you get, and then kind of plan for the future. That's the way I would put it.
All right. I think that it's time for us to conclude this session. But before we come to the conclusion of our conversation for today and wrap up, a quick rapid fire, to all three of you. What's one habit or mindset developers must adopt today to thrive in the AI-driven engineering future? Rohan, let's begin with you.
Okay, so I think one of the things which I always give a example that you can have all the tools, all the intelligence, you can be, but you still make mistakes, and we all come back as human beings saying, when somebody does something wrong, he should have had the common sense. So it's like if I go back to the AI part of it, then I'm saying you should have the AI sense. So you need to take a step back and say, is this really the thing? What could AI do for you or not do for you? Or was it hallucinating or was it there? So start having an AI sense I think that's more important. That complements with your common sense, and that's a way to navigate safely in the AI driven world now.
Vasu, what's your take?
So I'm sure there's a lot of Game of Thrones fans here. Winter is not coming. Winter is here right now. It's in your homes, in your offices. Embrace AI change. There's a question that people keep asking, will we lose jobs because of AI? Absolutely. You will be replaced by somebody who knows better than you on AI. That's what it is. You'll never, nobody will lose the jobs actually. Will elevate to the next level. But if you do not embrace the change and this AI tooling and everything, definitely you'll be replaced. So hurry up, embrace the change.
Great. Jay?
See, I have like a couple of points. One is like you need to leverage AI. Okay, what is available today in the market, leverage it. At the same time, evolve with AI. What is like new kind of stuff kind of arriving in the market, you need to evolve along with that. While actually you do that, you actually need to adapt to the new way of working. Okay, it's like a new environment or new ecosystem is getting created. So adapt to the new way of working. And as we already said, don't blindly believe AI. So this is like the review and the refine. Okay, the R, which actually is very important. And then the final one is like the new skills which are actually required. Okay, system thinking, platform engineering, soft skills, and other stuff. To summarize, it is like LEARN, learn framework. Okay, leverage AI, evolve with AI, adapt to the new way of working, review and refine, and new skills. So it's a learn framework we need to adapt for the future.
All right. So, as a conclusion and wrap up to our conversation for today, it's very prevalent that AI is not just reshaping how we build software; it's reshaping how we think about engineering. And all three of you have, substantiated that part for us. And as we've heard today, you as leaders are now tasked with not just adopting AI tools, but rethinking the very structure of developer workflows, security models, and the learning paths, of course, for the teams that you have. A big thank you to all three of you, Jay, Vasu, and Rohan, for sharing your vision and expertise with us. Thank you, our audience, for tuning and sharing some exciting questions for our leaders. Stay tuned for more such discussions on Tech Leader Circle. Until next time, take care and keep building. Thank you.
Thanks, everyone.
Thank you. Thank you very much for having me.